Hey there, Mr. Weaver here, and this is Geometry Lesson 5, Distance Between 2 Points. After this lesson, you need to be able to use either the distance formula or the Pythagorean theorem to find the distance between two graphed points. You'll know you're successful after this lesson if you can use the distance formula by plugging in numbers or the Pythagorean theorem by making triangles to determine the distance between 2 points. First, let's just look at the distance formula. So the distance formula looks pretty complicated, but it's actually just the Pythagorean theorem in disguise. In the formula, we have x1 and y1. Those are the coordinates of the first point, and x2 and y2 are the coordinates of the second point. The distance formula is just saying how far apart are the x-coordinates, how far apart are the y-coordinates, then you square it, and then just like the Pythagorean theorem, you take the square root to find that final side length. So let's use the distance formula to figure out the distance between 0, 3, and -2, 7. The distance formula is usually better when you don't have a graph available, but for now, I'm going to show you what it looks like on the graph as well. So there's 0, 3, and -2, 7. I want to know how far apart those 2 points are. So there's my line indicating the distance. I'm going to use the distance formula. So here we have it. My 2 coordinates, 0, 3, and -2, 7. I'm going to say that 0, 3 is x1, y1, and -2, 7 is x2, y2. For the distance formula, you just need to plug those numbers in. So I'm going to plug in 0 where x1 is, and I'm going to plug in 3 where y1 is, and I'm going to plug in -2 where x2 is, and 7 where y2 is. It would look something like this. Then, just be careful with your subtraction, especially dealing with negatives. So -2 minus 0 is -2. 7 minus 3 is 4. Then square them. -2 squared is 4. 4 squared is 16. Add them together, we get 20. So our distance is the square root of 20, which is about 4.47. So the distance between those 2 points is about 4.47 units. So that's the distance formula. You just take your coordinates, plug them in, simplify it out, and get your answer. Now it's your turn. Use the distance formula and see if you can figure out the distance between 1, -4, and 5, -6. Let's check. You should have found that d, your distance, was also the square root of 20. That's just coincidence. It's not always going to be that. Your coordinates, x1, y1, are 1 and -4. x2 and y2 are 5 and -6. As I said before, be super careful with subtracting. You can see in that second area here, we have -6 minus -4. So we're actually subtracting a negative, which gives you -2. Simplifying it out, we end up with 20 again, so 4.47. Let's look at another example, but this time using the Pythagorean theorem. So what's the distance between 2, 9 and -3, 4? The Pythagorean theorem is way more useful when you can graph the points or if they're already graphed for you. So here I can graph the points, -3, 4 and 2, 9. The distance between those, I'm going to say that that is the hypotenuse. Then I'm going to make a right triangle using the grid lines. By doing this, I can count how long the legs are. So here, the bottom leg is 5, and the side leg is also 5. I just counted and saw how long they were. Now I can use the Pythagorean theorem. So a squared plus b squared equals c squared. plug in my legs. So 5 squared plus 5 squared, 25 plus 25. So c squared must be 50. C, the side length, is the square root of 50, which is about 7.0 something. So for the Pythagorean theorem, I just made a right triangle using the grid lines and did the Pythagorean theorem to find the hypotenuse. Now it's your turn. Pause the video, find the distance between 1, -5 and -6, 2. This time, use the Pythagorean theorem. Let's check. You should have found your answer to be the square root of 98, or about 9.8 or 9.9 something. Here's how to get that. Here's your 2 points. Connect them for the hypotenuse. Draw your legs. This time both legs were 7. So 7 squared plus 7 squared, 49 plus 49 is 98. Square root that to get your answer. In both of these, the legs happen to be the same length. That is just coincidence. They're not always going to be that, as we'll see in the next example. Let's put our finding the distance between points into an application of perimeter. So what is the perimeter of the triangle? For this, I'm just going to use the Pythagorean theorem since it's already graphed for me. So each side of the triangle is going to be the hypotenuse of a different triangle that I make by using the grid lines. So first, I'm going to take that side, make a triangle that's 2 wide and 9 tall. So 2 squared plus 9 squared equals c squared. Calculate it out. I should find that that side length was the square root of 85. If I take another side length and do it again, this time my right triangle with the grid lines is 5 and 6. Calculating it out, I get square root of 61. And our final triangle, calculating it out, square root of 80. So for the perimeter of the triangle that was given, I found the side lengths by creating new triangles and finding the distance. Now, we want the perimeter, which means we need to add all the sides together. If I do that, this time I'm going to approximate it, and it's about 25.97. Now it's your turn. What is the perimeter of the triangle shown in the graph? You should have found that it was about 24.27. Here's how to get that. One side of the triangle was the square root of 85. Another side of the triangle was the square root of 34. And the final side of the triangle was also the square root of 85. Adding those together, you get about 24.27. In this lesson, we learned that there were 2 ways we can find the distance between 2 points on a graph. So if we need to find those points, we have 2 options. The first is to use the distance formula, which is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Complicated, but we're just plugging in numbers. For this, if we know the 2 coordinates, we just call them x1, y1, and x2, y2, and then just plug in the values and calculate it out. This method might be easier if it's not graphed ahead of time or you're not given graph paper to use. You're just given the coordinates. Our other option is to create triangles using the distance as the hypotenuse. If we do this method, we're just using the Pythagorean theorem to solve for the length of our unknown side, which is the distance between the points. That method might be easier if the points are already graphed for you. Either method is going to work and it's going to come up with the same answer, so choose the one you're the most comfortable with and the one that works better in the situation. So after this lesson, do you now know how to use either the distance formula or the Pythagorean theorem to determine the distance between points? As long as you know how to use one of those, you are good. And that's the end of lesson 5 of the distance between 2 points.